Hi, I'm Snen, and this is a devlog to log my progress with the Rust programming language and the Bevy game engine. I've been sort of toying with this stack for a while now, about a couple of years, trying out different crates in the ecosystem, learning how to use the various tools, as well as, just generally having fun. But I haven't built any games yet, and I'd like to change that. So this devlog is going to track my progress as well as sort of keep me accountable as I go along. I hope you enjoy. So the game I want to talk about today, I'm calling Cricket Pong. It's just a variant of Pong, the Atari classic, where, in Pong, there's effectively these two goalposts. There's a ball that's going to bounce between those two goalposts, and you have a little paddle that you use to try and defend your side. When it hits one side, somebody gets a point, and that's basically it. So all I wanted to do with this idea was put it in a circle. So there's somebody trying to protect the outside and somebody trying to protect the center of the circle. When I thought about this, it kind of reminded me of cricket, international sport. I'm not super knowledgeable about cricket, and the analogy is not the most robust, but I thought it was a neat little analogy, so I'm working with it. Basically, I'm going to put a batter in the center of the circle, and you're going to swing the bat and try and protect the ball from hitting the wicket that way. I'm calling it a wicket, just like in cricket. And then on the outside, I'm basically borrowing from table football, also known as foosball, where you basically have these sort of dudes on a track, and the dudes on the track are kind of hitting a ball back and forth. So the batter's going to have their bat, and the fielders will have these little paddles on two different tracks, rotating around, so trying to defend the ball from hitting the outside. So there will be somebody who bowls the ball, or not somebody, but a thing that bowls the ball towards the center. The batter's going to swing the bat, and then the fielders kind of have to move around to try to catch the ball from going to the outside. Here's some video of my wife and I playing the finished product. Well, not quite the finished product. There's a couple of small changes I made after this take was made, but as you can see, neither of us is particularly good. If you look in the corners, you can see like little scoreboards for both the batter and the fielder. It switches every 6 pitches, and in cricket that's called an over. So I have this little scoreboard in the bottom left where it shows the result of each pitch for that particular over. One of the changes, actually a bug I fixed after this take, was that in this game it doesn't show it, but since it seems a little harder to be the fielder, I also made it so that, if the fielder sort of touches the ball enough times before it goes either to the wicket or out of the boundary, then the fielder will score 1 point rather than the 3 points that they get if they hit the wicket successfully. So I want to show a little bit of the code involved, but before I do that, I think it's probably worth talking a bit about the Bevy game engine and how it works. Bevy provides what's called an ECS architecture. ECS stands for Entity Component System, and those are basically just the 3 central concepts that relate to how you're going to organize your game logic. Entities are sort of like the game objects that you spawn them and then they exist in the game world. But they won't do anything until you add components to them. Components are the actual data types that sort of track whatever state your game needs to contain. So maybe that means the health points of a character, or its velocity, or its position on the screen. The way you're going to actually define game logic then is that you'll have systems, which are just functions. They're special functions, and those functions will basically operate on the component data for each entity. I really like working within this model of how to define your game logic. It helps define things in more modular ways and sort of more encapsulatable ways. You can say this stuff is just for my gameplay, this stuff is just sort of how graphics works, or whatever specific parts of the game logic you want to encode in a specific system, I guess. One of the other really nice advantages here is that Rust is really good at compiling to various targets. So actually all the recordings of the game from before were its WebAssembly build, which is running live on my website. at lab.snen.dev, which means you can play it anytime you want. So feel free to go check it out. The code for the game is also on GitHub if you want to take a look. I think this video is long enough already, so I'm going to do a brief tour through it, but not spend too much time. But basically, there's a few different subcrates involved that are all kind of joined together to make the full application happen. There's this base, which it basically has all the individual elements and data types that are used to construct the game. This batter type has a few useful constants on it that help me make sure that things like the size of the collider in the physics library, as well as the size of the actual graphical rectangle, have the same sort of positioning and size and things like that. Then there's the actual game crate where I define all the system logic. You can take a look through this if you want. It's sort of too much to go through here. For controls, I'm handling controls through this Leafwing Input Manager crate, which is a really useful tool. I'll add it in the link below, as well as links to all the other tools that I'm using and things I've mentioned. But you can usually find them on crates.io or on GitHub. And finally, this is the graphics, where basically pretty much every time I'm detecting that if one of my base types has been added to some entity, then I'll make sure to also additionally attach whatever appropriate graphical elements are involved. Some of these sort of patterns that I'm using aren't entirely necessary, so if you're looking at this being like, why is it so complicated? Part of it is just future plans, things like adding netcode and just experience I have with previous sort of toy projects. So a lot of our sort of overall style could be a little bit more straightforward. So if you're going to get started using Bevy, I wouldn't necessarily use this as a template. It's just sort of how I've learned to write my code. But yeah, if you want to learn more about it, definitely feel free to pull the code and check it out, and just run it, I guess. The app crate is the one that sort of contains the actual full build. And there's a test you can run in the game crate that will show debug graphics for the physics colliders and things like that. That's all I have for you today, though. If you watched this whole video, thank you very much for doing so, and I'll see you next time. Bye.